So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you know, this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to any project that they are doing or concepts of RCC steel design or any construction site issues. So, this is the 26th such session, and welcome all of you who are joining us today. So, let us start with the questions. As we always do, first I'll take questions that have been asked on the Google form. Then we will have a look at questions that have been asked on the email, and then we will take the questions from live chat. So, if you are attending this session live, and if you want to put some questions or queries, you can put it on the live chat also. We will take up towards the later part of the session. So first question asked is the first question that has been asked is by engineer Vasu Bhadania, and he is joining us from Junagadh, that is Saurashtra in Gujarat, and he has a list of questions. So Mr. Vasu is an independent consultant, and he has a list of questions that he has put. So let me start by answering his questions. So I'll share my screen, and what should I do? Let me share my screen. Yes. So these are his questions. Let's take them quickly. So his first question is, when the analysis is done for only static loads, should we use stiffness modifiers or should we use them when only dynamic loads are applied? Then if we can create two cases of analysis, which one we have to use? Load cases with dead live. No, so I think you are getting confused with this modifier thing. You refer IS 16700. See, as of now in IS 456, we don't have any modifiers given. As of now, the current version of IS 456 that we use, that is the 2000 version, does not have any modifiers, no mention of modifiers, whether for analysis or design. If you look at the IS 1893 Part 1, it mentions the use of modifiers, but only for analysis. That means modifiers only for some drift and deformation checks. Okay, only for drift deformation checks. It mentions the use of modifiers. This I am talking about the 1893 Part 1 and IS 456 2000. But if you look at IS 16700 2023, and if your structure is more than 50 meters, 50, so it complies with the scope of 16700 2023 code. Then in this code, they have given you modifiers to be used. In the 2017 version of 16700, the language was slightly confusing. It was a great, so I would say it was a source for great confusion in the minds of engineers, because if you refer the 2017 version, it said that modifiers for factored loads and unfactored loads. So it was a cause for great confusion. Has anyone referred to the 16700 2017 version? Anyone? If you remember that old version of the code, it had two tables for modifiers. One was called as the modifiers for factored loads, the other was called as modifiers for unfactored loads. So it was really not very clear, because sometimes what happens, one interpretation of that was that wind loads, because we design our structures for wind loads at elastic level, so usually we may call the wind loads as unfactored loads. Earthquake, because we take only a fraction of earthquake load for our actual design, some people used to call earthquake loads as factored loads. So there was a lot of confusion with the 2017 table. I think this question comes from that confusion only. So let me just clarify. If you are using 16700 2023, code is quite clear that for service limit states, there is a modifier table that has been given to you. And for ultimate limit states or strength design, So for service design, there are one set of modifiers given. For ultimate limit state or so sorry, for service level design, one set of modifiers. For strength design or ultimate design, there is another set of modifiers that is given. So the confusion whether it is dead or wind or earthquake is now not there. Simple to understand. If you are checking for any service limit state, you will have to use one set of modifiers. If you are doing the design, that means if you are finding out reinforcements and checking sizes for any element, then you will have to use the other set of modifiers. Okay, just hold on. Yeah, so that is what I wanted to inform over here. So basically, if you are doing any structure that comes under the scope of 16700 you will have to make two separate models. In the first model, it will be used for the service checks. The second model will be used for ultimate or strength based checks. So I think this entire question can be answered in this simple explanation. Again, this is only applicable if your structure is being designed as per 16700 That means your structure is taller than 50 meters. If you are doing a normal structure as per IS 456-2000, as of now, whether for analysis or for design, there is no mention of any modifier use. So if you are using modifiers for structure being designed and analyzed as per 456-2000, then remember that it's not as per the codal provisions. Of course, the upcoming revision of 456 does mention the use of modifiers over there. But anyway, short answer is that don't be confused about these things. If you are using 16700 simple thing to remember, there will be two sets of modifiers given. If you are doing service limit state checks, one set of modifier. If you are doing ultimate limit state, second set of modifier. I hope that answers the query. The next question being asked by Mr. Vasu is, if a steel column for two floors is to be provided, then should it be used as entire column, or would it be wise to provide two separate columns? Very good question he has asked. So he is saying, suppose you are doing a steel building, and I'll just draw uh, something like this. These are, let's say, columns. Okay, and then these are beams. I hope the diagram is visible. These are columns, and then these are beams at other level also. Just hold on. So this is case 1, and in the case 2 what we are doing, so in the case 2 we are doing something like this, and then I'll ask you that which case as a design engineer would you recommend. So let's say this is my case 2, and I hope someone can identify the difference between these two cases. Okay, so what is the difference between these two cases? Can anyone uh, is able to identify? So this is my case 2, and this was my case 1. Yes, please. Difference. So difference in these two cases is, if you can see that in the first case what I have done, this is a steel structure. These are my columns. This is my beam. So in the first case, I have taken the columns through and through. All right. And then at the beam column junction, I have taken my column through, and then beam will be sort of connected on the column over here. Okay. In the second case, what I have done, I am taking columns as breaks like this, and then I'm going to, uh, let's say I provide this beam. Okay. and then on top of that I will provide the next piece of my column. So that is case 2. So according to you, all of you, those who are present right now, which system would you have suggested? Case 1, case 2, which system do you think is a better system? I hope you are able to understand the difference. In case 1, I had taken continuous columns, continuous columns, and beams are connected to columns. In this, in a way, columns are getting at story levels. Okay, and then column is getting connected to beams. So which of these two cases Mr. Umang is saying case 1 he thinks is better? See, execution wise, Mr. Balaji is also saying case 1 he thinks is better. Yeah. So execution wise and logic wise, case 1 is better, and that is what we will always do. In most of the structures you will see case 1 being adopted. The reason is many folds. There are many reasons why we would prefer case 1. Number 1 is the sequence of construction. Generally we will erect the columns first in a steel structure erection if you do it on site. So generally you will put your columns as a straight members first, and then you will connect the beams. So it will be very difficult if you start doing it like this case 2, that first you erect this much piece, then you put a continuous beam on it, then you again erect portions of these columns, then again you put a beam on it. It will be very difficult. So for such steel structure, yeah, of course steel structures, I'm talking about steel structures right now. In RCC this uh, issue does not rise, because in RCC we are doing everything cast in situ. Okay, so this thing about this thing will not arise in case of RCC structures. Everything is monolithic over there. In steel structures, this has to be understood. So I was saying that case 1 is the case which is more logical and more preferred. We will first place our columns, which will act as a spine of this system. Then we will start placing beams, or rather, beams then start getting connected to columns. Also, connection wise, it is simpler, because in this case what will happen if I start breaking columns in this pieces, you will have to develop connections over here. You understand? Most of the times we have to develop rigid beam column connections in our frames, structural frames. So at these locations you will need connections to be developed. Now the location over here, developing connections is much more difficult if you see, rather than developing a connection like this. This beam column connection is simpler to develop on site as compared to a connection where my column is supposed to rigidly be connected with my beams. Also, the number of connections, if you see, will be more in case 2 as compared to case 1. Yes or no? Total number of connections in my structure will be more in case 1. Sorry, will be more in case 2 as compared to case 1. So overall, system wise, stability wise, connection, ease of connection wise, the way in which fabrication is done, looking at all those things, this case 1 is what we are going to prefer. There is a clause also, there is a mention also in the code about these two cases. If you refer IS 800 2007, I'm forgetting the exact section where this is mentioned, but they quite clearly say that if you are using this type of an arrangement where columns are to be broken at every floor level and something like this, then considering these connections as rigid, I think your code does not allow. I'm forgetting the exact clause number, but code is not allowing us to even assume that these will be credible rigid connections if you are doing something sort of case 2. So it is the case 1 that we will prefer. All right. So I hope these questions are answered. So this was Engineer Vasu with his questions. Now let me just take next set of questions that have been asked. And the next question is from Engineer Rushabh. He is a working professional, and he is saying that Where is this question? Okay, so are piles required to be designed for movements? His question is, Mr. Vrushab is asking, as in safe software, we do not provide any rotational stiffness. Correct. So see, pile, typically speaking, pile to pile cap connection is usually assumed as a pin connection. Okay, so if this is my pile cap and if this is my pile, pile to pile cap connection is assumed as a pin connection where movements are not going to be transferred. But then we do have cases where there might be a moment that is generated in the pile. So what Mr. Rushabh is asking, that if I am taking pile to pile cap connection as a pin connection, then why there will be moment generated in the pile? The reason for that is due to the horizontal reaction that your pile cap may have to take from your superstructure. So because of that horizontal reaction that your pile cap may have to take from the superstructure, there is a possibility that moments are generated in the pile. Now, because of this horizontal movement, what will happen? Assuming if my pile, of course, it's in the soil. So if I had a continuous lateral restraint from the soil below, practically would there be any movement? What do you think? If my pile was continuously supported throughout its length by soil, will there be any movement, bending moment in the pile? No, isn't it? But generally, what happens that the pile, we assume that pile gets lateral support from the soil after certain depth. Okay, so we will say that below certain depth, pile will get support from the soil. Just give me a minute, I'll be back. Yeah, so I was saying that below certain depth, pile will get support from the soil. Above that, the pile will not be considered to be effectively supported by soil. So what will happen that this, whatever this depth is, this is called as the depth of fixity. So beyond this, it is supported. Above this, we are assuming the pile to be not supported by soil. So if this was dimension h, then the moment in the pile will be how much? H into h. Understood? So even though my pile to pile cap connection is being assumed as a pin connection without any moment transfer, but because of this depth of fixity thing, you will get a certain moment in the pile. So whatever is the horizontal thrust you are getting in the pile cap, from there the moments will be generated in the pile due to the uh, concept of depth of fixity. Now, how to calculate this depth of fixity? So people use some softwares like L-Pile also. So there is a software, commercially available software, L-Pile, where you will have to model the different layers of the soil, and then it is able to calculate the depth of fixity. Or empirically, you can use the IS 2911 part 1 section 3, I think appendix number C, if I remember correctly. It gives you a procedure to calculate the depth of fixity. So how you have to proceed is that you need to calculate the depth of fixity, and then you multiply the horizontal thrust by that depth to get the moment in the individual pile. Once you get the moment in the individual pile, you already have the axial loads in the pile. So then you will have to design your pile for axial force and moment. Understood? So just like we do for our columns, you could do it for piles also. In this case, you can assume the pile to have a length of only this much. Below that, because we are assuming it is to be supported, So this is the length of pile that is assumed, and then you can design this pile for combined axial load plus moment. So many design engineers then they will use SP16, simple SP16 curves for it, or any other alternate column design procedure they will use for this type of pile arrangement also. So is this clear? So you'll have to find out the depth of fixity, and then multiplying the horizontal thrust with it, you shall get the uh, moment in the pile. Okay. Okay. So I this was what Mr. Vrushab had asked. Then I go to next question. This next question is being asked by engineer Nihal. He is a working professional, and he is saying how to design this type of connection, and he has shared one image on the WhatsApp. How to design this type of connection, image shared on WhatsApp. So I'll just bring that image. Let me just bring that image first. Yeah, so he has shared this image. Is this image visible? So this looks something like of a pin, and I'm not sure what is happening over here. Which member is getting connected to this pin? I'm not sure. Looks like some pin connection. So I'll just explain basics of this kind of a connection that you may have to do. And let me just check. Acha, it is not a pin connection. Mr. Zafar is informing that it is a lifting lug. Is it? Okay. Okay, so this is a hook and they are going to lift something from here. Is that it? Is that so? Okay, I thought it was a pin like connection. So you are saying that they are going to lift something from here. Is that so? And then it is connected to this member. Acha, tension cable is connected. Mr. Nihal is informing tension cable is connected. So this is the tension cable. I believe this is the tension cable in green. Is that so? Yeah. Green line, correct. Okay, got it. I was thinking that this is like something pin connection. Okay, so this is a tension cable that is connected. So things are easy then. This is, let's say, some wire rope sort of an arrangement. It's being pulled by some tension. You have this hook provided. It has a circular eye. In this eye, you will have that tension cable with a turnbuckle arrangement or some sort of connecting element that will be attached to this hook, and then you are going to pull this. So it's easy. You have this tension force. You first of all you find out the bearing. Okay, so what you can do is that maybe perpendicular to this section, on this cross section you find out the rupture strength of your plate. Okay, so rupture strength will be found out for the rupture strength of net area, correct? I hope you would be able to do that. So maybe perpendicular to this tension line, on this cross section you find out the net area into thickness. So in the net area you will have to subtract the whole dia into whatever fu, sorry, and whatever is the safety factor. I think it is 1.25. So basically what I'm telling you, you find the rupture strength on the net section, you find the yield strength of this, again maybe on a perpendicular line you can find out the yield strength. So yield strength you will find on the gross area. Correct? These two things you will have to do. Then what you do further, that their tension force is like this, you are going to do the welding over here to the member. So if you are doing it as per the Indian standard, what you need to understand over here, that you divide this into components, whatever. So this is t cos theta and t sine theta. Now these t sine theta, let's try to check for our welds. So t sine theta will generate a perpendicular weld stress perpendicular to this weld length. So I think those are called as your F stresses. F stresses or Q stresses? Stress perpendicular to the weld length as per Indian standard. Is it called as the F stress or Q stress? Hello. Mm, I am not able to recall whether it is called as the F stress or Q stress. I am saying when the force is perpendicular to the weld length, then as per the Indian standard, what is the nomenclature that they use? I think they use the F stress. Someone may just check it. But what I remember is that they use the term as F stress. So I'm writing it as F stress. So F stress in the weld due to T sine theta component. Then Q stress in the weld due to T cos theta component. How will you find out the stresses? You have the forces, dividing the force by your weld length. I'm assuming welds provided on these two sides of the lifting hook plate. So 2 times weld length into throat thickness effective. This will give you the stresses. I'm calling it as the F stress. And similarly, you will find out the Q stress. Once you get the F stress and Q stress, then you can find out the resultant also. Again, if someone can just help me out with the resultant stress, I think this is how the equation goes for resultant stresses. And all these F stresses, Q stresses, resultant stresses have to be less than the permissible weld stress. So in this manner, you can check this lifting hook and its connecting plate. Okay. All right. Of course, then whatever is the force that is going to be transferred to the member below, to this whatever chord member this is. So then you could transfer maybe in STAD analysis or wherever ETABS analysis, you could transfer this force to the bottom member and accordingly design that as well. All right. Okay. So this was Engineer Nihal with his question. Then we have Engineer Praveen Raj. He is also a working professional. He is asking, when including chapter 12 in design as per Indian standard, do we need to include crane loads also in chapter 12 load combinations? Chapter 12 of which you are, I'm assuming chapter 12 of IS 800 2007 you are saying? That is what I'm assuming. I'm assuming you are asking a question related to chapter 12. Those are the seismic requirements for steel structures. So first of all, please remember that now the chapter 12 has been superseded by IS 18168, 18168 2023. So chapter 12 now no longer is valid because it has already been superseded by a code on ductile design and detailing of steel structures, that is 18168 2023. So technically you are not supposed to now refer to chapter 12 anymore. However, your question is that when you are including, let's say, even if you are doing it as per 18168, why are we not including crane loads? Or should we include crane loads? Should we not include crane loads? I think that is your question. So you need to understand that the probability of cranes uh, being operational at the same time when an earthquake hits, that probability is quite rare. So accordingly, you will have to do the adjustment in the load combinations. Typically, we do not assume for this worst case that your earthquake hits when your crane was fully loaded. So that's why if you see the load combinations given in IS 800 2007 also, the factors are accordingly adjusted. Same thing we do for wind loads as well. So we do not consider full wind loads or wind loads at basic wind speed level uh, when our cranes are operational, because we assume that that is quite a worst case scenario, and generally that much risk we allow in our structural design. So my short answer will be I don't think you need to include crane loads when considering the earthquake load combinations. All right. Okay. Then, so this was Engineer Praveen Raj with his question. Next question is by Mr. Umang Patel. He's from Nashik and he's a postgraduate student. He's asking, can we analyze, model, design deep beam in ETABS? And if yes, then shall we model it as a shell element, pier or spandrel, or beam element? And if not, then if we use some other software, shall we design the deep beam as membrane? So you can do, see, short answer, you can model deep beam as shell element in ETABS and then assign spandrel labels to it. That is what you can do. But number one thing doing this, it is first of all time consuming, because then you will have to model the openings and model everything in great detail. And let's say in your practical design project, if anything changes, if any opening position changes in your uh, deep beam, these deep beams, I'm talking more about the connected deep beams, let's say between two shear walls. Now usually where do we need to have the deep beams? So in plan, maybe if this green was one shear wall, this was another shear wall, and I wanted to have a coupled shear wall with this sort of a link element. In elevation, maybe it looked something like this, that this was my shear wall across several stories. Okay, these were my story levels, let's say different story levels, and then I have some link elements connecting like this. Okay, are you with me, following what I'm saying? And maybe here you have planned some door openings. So this is my door opening, this is my window opening. So number one option is that you model everything as a spandrel element. So in that case, what you need to do, you will have to model this entire thing as spandrels and then create openings over here. Of course, that is quite time consuming, and because of so many shell elements, it will slow down your model analysis time also. So either you do this or you forget about this and just model it as a single line element like this. Now, what I have observed in ETABS after comparing both these models, that if you do it as a line element, if you do as a spandrel shell element, of course, these shell elements give you better and more realistic results. But even with beam elements, that means modeling your deep beams or spandrels as line elements or beam elements, your results are not off the mark by a large degree. So I would say, to save time and for practical considerations, I would suggest you to go for link beams modeled as line elements. It does not it does not lead to substantial variation in the results. Okay, if you wanted high level of accuracy and more exact behavior, then you could model your spandrels as shell elements, actual shell elements. But as I just informed, it will be time consuming and it will slow down your model, so generally we may not prefer it. So you could model your link beams as beam elements or line elements. Second problem is when you model your spandrels as shell elements, actually there is some error that ETABS commits in the spandrel design. So I have checked it myself. The lever arm that it is taking ETABS when we assign or when we make shell elements and assign them as spandrels, there is some mismatch in the ETABS outputs, especially because it takes the lever arm of that deep beam incorrectly. So short answer is you do it as a line element. When you do it as a line element, ETABS will not do the deep beam design very well, but then you could do it, the deep beam design part, you could do it manually. All right. So you could do some manual calculations for the deep beam design part, because when you model it as a line element, ETABS is not going to take the deep beam concepts properly. So you could take the analysis results from these line elements and then do it manually, the calculations for deep beams. Okay. So I hope that answers your question. Next question is from uh, Balaji, engineer Balaji. He is asking, I would like to have some clarity on how to calculate the eccentricity values at each floor. See, eccentricity values at each floor basically is the difference between the center of mass and center of rigidity. Okay, that in simple terms is the eccentricity. So if you have this kind of a plan and these are your lateral load resisting elements, okay, these blue boxes I'm trying to draw are my lateral load resisting elements. So first you have to mark the center of mass. Center of mass will be, if your load distribution is uniform, generally it will be the geometric center. And then on the basis of rigidity of each element in a particular direction, you'll have to calculate the center of rigidity in both directions. Let's say my center of rigidity lies over here. No, sorry. Let's say your center of rigidity lies slightly over here. Okay. So I'll assume that the earthquake load, the concept is that the earthquake load acts at the center of mass because it's an inertial force. So earthquake force is acting at the center of mass. The resistance being offered by the structure is offered at the center of rigidity. So this is where EQ acts. This is where the center of, or this is where the rigidity to that inertial force is offered by the structure. So now how to calculate eccentricity for earthquake in X? Let's say this was earthquake in Y direction, and this is my reaction to Y direction earthquake. The eccentricity that you get is this, okay, EX. And similarly for X direction earthquake, earthquake will act over here. Response to this earthquake, you get it from here. So the eccentricity is this. Okay. So this is how you have to calculate eccentricity. For at each floor, you will have to calculate the difference in the center of mass and center of rigidity. Accordingly, you will get two eccentricities in X and Y. Then you will have to use them in calculating your in plan torsional moments. So that is what your code also tells you. The image that you had shared, that is the same image. This image, this clause from the code is telling you the same thing, that you have to take in account the effects of eccentricity in your structure. So this ESI term is the static eccentricity. This is the difference between the COR, that is center of rigidity, and COM, center of mass. So this is being termed as ESI. Then you have to take some accidental eccentricity. Now this may be due to the some differences in construction, or under the effect of earthquake event, some changes in the rigidity and center of mass that may happen. So then you have to consider this accidental eccentricity, which is taken as 5% of the width. So if you are taking earthquake in Y, you will have to take this dimension and take 5% of it, 0.05 B1. If you are considering earthquake in X, then you have to take 5% of B2. And then this 1.5 is the amplification factor mentioned. So then these are the two dynamic eccentricities that you have to, or sorry, design eccentricities that you have to work out. So usually all softwares do this type of operation on their own. You don't have to be very worried about what's happening, but this is the basic of what you need to understand. Okay. All right, I hope you got your answer. The next question is from engineer Anukul Kumar. He is joining us from Delhi, and he is a postgraduate student. His question is his question is in design of rotary. Just hold on, please. Yeah. So he's saying in design, Anukul Kumar, his question is in the design of rotary machine foundations. I understand that to avoid resonance, the natural frequency of foundation should differ from this at least 20%. However, I would like your expert analysis on interpretation of results from forced vibration analysis. I have not done this, so I'm unable to answer because I don't have much working knowledge on it as of now. For example, if the unbalanced dynamic load is 6.49 kilonewtons, uh, acceptable criteria, you can refer to IS 2974 part 3 and I think part 4. These are for foundations for rotary machines. Part 3 is for uh, machines having medium and high frequency, and part 4 is, I think, for rotary machines having low frequencies. So, what your question is, depending on the RPM of your machine, you can go to this IS 2974, either part 3 or part 4. Accordingly, you will have to check for the standard clauses, codal provisions, and acceptance criteria. They do give you the calculations for the permissible amplitudes, how to calculate the time periods, how to achieve a frequency shift between the natural time period of your foundation system and the machines. So all those data is given in 2974, either part 3 or part 4 for rotary machine foundations, depending on the RPM of your foundation. So that is my answer. Please refer to these documents. About results of forced vibration in STAD, I don't have a proper answer right now because I have not studied it in detail. Mr. Anukul is saying, I have checked, there isn't any recommendation for forced vibration. Is it? You have checked these two parts, 2974, part 3, part 4? Okay, so if you did not get, then maybe you will have to refer some international codes. As of now, I don't know which American code, let's say, is there any ACI code or is there any European code for it? As of now, I'm not quite aware of it. So, no answer right now that I have. Last time that I had checked these two codes, I could find some recommendations, at least for acceptability criteria, the frequency shift, the time periods, amplitudes. For these, you do get provisions. But you are saying that you did not find any recommendation. So as of now, I don't have a proper answer for this question. Okay. Okay. The next question is by engineer Nikunj. He is joining us from Latur, Maharashtra. How to design trussel slab shuttering, and he has shared some images. Let me put his question first, and I think then I'll just take some photographs also that he has shared. Where are his questions? Just give me a minute. Yeah, I think he has shared these images. So a typical bridge-like system, generally what happens is that these bridges, uh, their shutterings are usually designed, and if this the shuttering arrangement has to be usually, you need to get it approved before you can start construction. You need to get these systems approved usually. So that is what he's asking. So how this arrangement typically looks like, let me just show you, try to show you over here. So typically there will be a bridge deck, okay? Whatever is your bridge deck in plan view, let's say this is your bridge deck. So this is where the mass concrete of your bridge deck is going to happen. So typically what you do, that you will have some girder arrangement, one level of girder arrangement at certain distances, okay? These will be usually your ISMC channels. Below this, you will have your main s- another system. So these magenta lines will be below the blue lines. Blue lines, let's say they are the secondary members. Magenta lines are your primary members, let's call them as. And then you will have these primary members getting supported on columns. Those columns usually we make out of built up sections. So usually there will be four angles. We make a four angle like this in plan view, and then we will tie it up with lacings. So usually this is called as a trussel. This is called as a trestle system. So these black rectangles that I'm trying to draw, these are my trestles. So this is a three tier, basically two tier framing, okay, and getting supported by trestles. So Mr. Nikunj is asking, what is his question? How to design this shuttering for bridge deck construction and analysis. It is in StatPro. How to model it? Is it required to model entirely or just model the trestle? Yeah, so you could see, you could refer some design reports for this if you have any access to design reports. Basically what they do, they will, some people make a full model, some people just do manual calculations, quick manual calculations for it. If you want to do, you could do a full small little model also. In my opinion, no need to model these trussels, model them as line elements. uh, Trestle don't need model them as four elements like this. You model them as line elements and take the property from section wizard. So in section wizard, you make your four angles. Don't model the lacings, just model the four angles trestle. Import it to your STAD using the UPT file, and then model these trestles as single line elements, property being defined from the UPT file. On top of it, you could have make your primary beams on top of primary beams. Of course in STAD you will not be able to do it at two tier level. So in the same level, at the same level, you could model your secondary system. On top of that secondary system, you could apply loads. Generally load application, you can do it as one way slabs, because shutterings generally are composed of steel plates, and because they are usually supported across their short span. So you apply the loads on these trestles as UDLs. Okay, sorry, not trestles. You apply the loads on these beams, secondary beams, as UDLs, and then you consider the basics of dead load, live load. Some people do consider some wind loads also, although this trestle system is a temporary structure, but still, because as per IS 875 part 3 2015, they do require us to consider wind loads for temporary systems also. So you could consider temporary loads. And so do all these things, then consider the load coming from deck slab, take the impact loads, etc. Find out the moments, axial loads, whatever, and then design your trestle and this entire system. Okay. So I'll recommend you, before you take up something like this, first understand some basics of steel design and try to get some report on this type of shuttering design from somewhere. You will understand how that trestle system is being provided first of all, and then how the calculations need to be done. Okay. So before jumping right away into it, I'll ask you, or I will request you to first have a look at some design documents. Maybe you could take some documents from your uh, previous from some previous projects or some engineers. Try to learn or try to study the arrangement first, and then model it and analyze design it. Okay, so these were the questions that have been asked on the Google form. Now I'll take to you to the live questions that have been asked. Let's try to take them one by one. So Mr. Magaj is asking how to check whether ETABS design shear wall as ductile or ordinary. Now, usually ETABS will design the shear wall as per the requirements of IS 13920, and surprisingly, ETABS still uses the 1993 version. So it will still use the 1993 version for shear wall design. Most of the times, even if you have applied, let's say, gravity loads only, it will still do the design as per the 1893, sorry, 13920 1993. Okay, so the design aspect is still being done using the older versions of 13920. Okay, then Mr. Magaj is asking, in zone 2 region I have seen most of shear walls are floated either on girder beam or the entire slab is thickened. Since we know that the floating should not be part of LLRS, so how much of this system is good enough for taking lateral forces? So see, in such cases, if they are discontinuing shear walls, first of all, either they will not discontinue the entire shear walls. Some shear walls they might discontinue at the transfer slab level. Other walls they will take it right till the bottom. So at the bottom level, whatever is the base shear, that has to be resisted by those shear walls which are continuing right till the footing level or raft level. Or if you are, let's say, trying to or going to uh, stop all the shear walls at your transfer girder location, then they have another system that they provide below the transfer girder. So then that lateral load resisting system will be uh, effective, or that system will then take those lateral forces. Okay, so it has to see in most of the structures, if you see for example the case of WTC, World Trade Center, which is not there now, but in that structure also it had closely spaced peripheral columns, and then it had a transfer system at first floor, I think, and then below that the column spacings increased. So then, of course, you will have to consider the system that you have provided below the transfer slab to be effective in taking the lateral loads. Okay. Mr. Vasu has some follow-up questions. No, I think I have answered his questions. Yeah. Mr. Vasu is asking, I think these are some follow-ups. When should we when should we consider stiffness modifiers for static cases or dynamic cases? No, as I tried to explain you, it's not about static or dynamic anymore now. If you are doing any strength based check, you have to apply modifiers. If you are doing service based checks, you don't have to apply modifiers. Simple. Should we apply modifiers on individual loads and then create load combinations, or should we apply stiffness modifiers directly on load combinations? See, I think you are asking this question from the point of view of Midas software that you are learning right now. In ETABS, the modifiers are not provided to load cases or load combinations. In ETABS, they are just designed, or the modifiers just applied to the entire structure. Okay. His third question follow up was obviously the case one is correct where we have taken the columns right through and beams are getting connected. But his follow up is, was it necessary to cut down column and provide column to column connection, or we can continue the section for entire length? No, so that depends on what length of column you can transport conveniently to site from your workshop. Suppose this column was 6 meters, okay, and you are able to comfortably transport 3-meter pieces, let's say, okay. So then what you will do, that of course you will go with case one, but then you will provide some splices. Now generally those splices in the columns, you will try to have it near the point of contraflexures, so maybe somewhere near the mid heights you could go for those splices in the column. So I'll not have a junction in the column right at the beam column panel zone. No, I'll plan, if at all a splicing is required in the column, I'll plan it at somewhere near to mid height where we get a point of counterflexure. Okay. Okay. So all right. So we are done. We have taken all the questions that have been asked on the Google form. We have also answered the questions from the email and in the chat also. So if anything else is there, you may ask, or we close today's session. Okay then. So that's all. Thank you so much for joining us today. The same link, as I have told you, the same link for Google Form. Mr. Raihan is asking how to design gravity columns. It's a long discussion. We had taken up gravity columns in one of our previous lectures. There are 4 or 5 strategies for it. In one of our earlier Ask AuxEn Anything session, we had taken this up. Maybe you could refer that. There are 4 or 5 strategies of doing this. In addition to that, you could also refer the 13920, I think chapter, no, 13920, chapter 11 or chapter 12, I think, which talks about gravity columns. So there are some complications related to gravity columns. I'll suggest you to have a look at the previous discussions that we have conducted on Ask AuxEn Anything. We have taken this question at that point or in that session. Mr. Anukul Kumar is asking, how do we model friction dampers in ETABS? I don't have any working knowledge of modeling friction dampers in ETABS, so I don't know. Okay, so if you have any questions, the same Google form link is there, which you can use for putting your questions. Once every week, we take your questions up during the live session that we conduct on weekends typically, but this link remains the same. You could ask your questions over there throughout the week, and if you want to get in touch with us over WhatsApp, I am putting the WhatsApp link in the live chat. You could get in touch with us over WhatsApp also. So that's all we have for this session. Thank you so much, and we will see you now next weekend. Thanks a lot for joining.